I am Robert Cohen, Technical Director at Energy Consultants Verco, and I'm going to talk briefly about how to address the gap between calculated and actual energy performance in the production of building energy performance certificates. I'm going to talk about the context, the main objectives of the protocol, give you an overview of the protocol, the tools and the indicators, tell you about applying the protocol, the main steps, and tell you some key lessons that we've learnt from the pilot studies. So the context and ambition. A key attribute of ALDREN's proposed harmonized energy performance rating based on the European Voluntary Certification Scheme is the verification of the rating by measurements. And this is because verified performance will increase trust in the rating. And we believe that a trusted rating should make it valued in the real estate market for offices and hotels, the two sectors that we are mainly looking at. In other words, a better energy rating will equate to a higher asset value financially. And why is this? It's because customers, whether it's the occupants of offices or the guests in a hotel, will preference buildings that have a better rating. And therefore, rents can be higher, vacancies will be lower, and that financially creates a higher yield. A higher yield necessarily creates a higher asset value. And the key consequence of this is that asset owners become justified to do deep retrofit with a better energy rating to increase trust. So the main objectives of the verification approach are, first of all, to ensure that performance is verifiable, to produce a verification plan, to put energy meters in the right locations, to be able to verify the predictions, to be able to adjust the boundary conditions in the model to match real conditions, and therefore to be able to focus verification on like-for-like comparisons between predicted and measured energy use. And lastly, to instill through the protocol a relentless emphasis on the energy performance outcome at every stage of the refurbishment process. I'll now give you an overview of the protocol. First, let's consider the conventional way that European countries assess the energy performance of buildings. If you look in the left-hand column of this slide, it shows each of the main ALDREN stages: decision, which means setting the requirements, developing the design, the detailed design, the building works and construction, and then, of course, the in-use phase. The next column shows how we normally assess energy performance. We calculate an EPC before refurbishment, at the design stage, and finally after building completion. We think of each stage as providing a lens onto the building, and we have labeled the three sequential EPC calculations lenses A, D, and E. What the verification process does is introduce additional energy assessments at the start of the project to inform a more insightful refurbishment, and at the end to check if the refurbishment achieved its energy reduction goals in the performance outcome, the measured performance outcome. Before the design of the building refurbishment is fixed, the existing building is audited to understand how much energy it is currently using and what for. The building model can then be calibrated against the real data. And this will require the model to be run under actual conditions of use rather than the standard conditions used for EPC calculations. After the building has been refurbishment and has experienced at least a year of occupation, the verification can take place. Data is collected from the energy meters and compared with predictions for the building, again under actual conditions of use. So I now want to briefly tell you the main steps of the protocol. They are shown here for each stage of the ALDREN journey. And the verification protocol is an Excel tool which tells you the key tasks that need to be undertaken at each stage of the refurbishment in order to meet the objectives, which are verifiability and higher energy efficiency. There is, by the way, an instruction manual as a Word document to tell you in detail how to apply each stage. So at the decision stage, it's important to get stakeholder commitment, to apply a simulation model consistent with EU SEN standards, and unless the building is unoccupied, to undertake an energy audit of the existing building. When you are developing the design, you need to calibrate the model using measured energy from the meters, agree the improvements to be undertaken, outline how the building will be controlled, set the performance target, and undertake an independent review of the proposals. During the detailed design, it is important to have the metering plan clarified and to develop the description of operations, which describes how the building will be controlled. During the works and construction stage, you have to defend the building against value engineering, take care with handover and commissioning to make sure the building is set up correctly, finalize the description of operations, how the building should be controlled, calculate the asset rating, and undertake intensive tuning against the description of operations to ensure the real building is being controlled as it should be according to the design. And then in use, you have to track the metered energy performance, diagnose deviations between the metered performance and the expected performance, implement improvements, and track the building's performance over the first year. So the building performance verification tool is used in parallel with the design for testability protocol and is used to signpost and monitor energy performance at all the various stages of the renovation. It also provides a purpose-built repository for predicted and measured energy consumption through the ALDREN process and calculates the performance gap both at the decision stage and the in-use stage for each energy system in the building. So how do we go about deciding whether the performance is verified? We have created a traffic light system which we apply to each significant end use, which is defined as an end use with total consumption in kilowatt hours per square meter, which account for more than 10% of the total consumption covered by the European Voluntary Certificate. And the traffic lights say that where the values for the end use between predicted and measured performance are less than 25%, you are given a green light. Where the difference between predicted and actual energy performance is over 25%, but due to different uses by different energy carriers, you may get an amber light. This is because some energy uses are provided by different energy carriers, such as electricity or heating or fossil fuel. Where the difference for each end use, each significant end use, is greater than 25%, you get a red light. So where all end uses are given a green light, the building is said to have a verified energy performance. I want to finish with some key lessons that we have learnt from applying the verification protocol to various pilot studies. The first one is that the conventional approach to modelling is not suitably detailed to enable verification. We recommend full compliance with SEN standards for the simulation model, which includes modelling of HVAC plant and their controls. We have also found that the submetering installed in actual buildings is often not ready for verification purposes. It is not correctly calibrated, or it is even not working at all. We have found that building controls are not working as they are designed to, and that can be put right. And we have also found that designers are fixated on their theoretical performance as opposed to the operational outcomes. And some of the independent design reviews, which showed that in operation, the building would not perform as desired by the design, these recommendations tended to be ignored. Those are some very high-level lessons from the pilot studies about verification. But to finish, I would like to simply say that if we can achieve an EU-wide building energy performance certificate verified by measurements, this will help real estate owners to justify the deep retrofit that we need, because better performing buildings in reality will appeal more to building occupiers, and this should increase their value, and that will justify the expense of the deep retrofit. Thank you very much for listening.